here's one of the harder questions on the paper here. So this is the old classic find the equation of the perpendicular bisector. So what we have to do is we have to be really careful. The equation of the perpendicular bisector between C and D. So visually, here's C, here is D, and here is, look, the perpendicular bisector of CD. So that is exactly halfway in the middle, like this. And that's what we're trying to find the equation of. So there's some clues here, right? So we need to look at the clues. Can you see the gradient of this is definitely negative? It's downward sloping. Now, while this diagram isn't drawn to scale, you can get a sense that the y-intercept here is somewhere, right? Somewhere around, you know, 0s, 1s, 2s, maybe. Okay. So there's a little clue there that we're going to try and stick to and see if that's going to help us with the actual solution, right? So there you go. Look, oh, that's 4 here, so somewhere around that point. So let's go and try it. Now there's a few steps. You've got these steps in your notes. Step 1 is let's find the gradient of CD. Now that is y2 minus y1 over x2 minus x1. Now you can go back to the diagram. Here's C and here's D. And you can actually draw your nice triangle on here, right? You can go and draw a vertical line, a horizontal line, and you can think of it like this, right? And then we've got to find the gradient is this distance over this distance, the rise over run. Okay, so you can think of it that way. Or you can just go ahead and label the points. This is x of 1, this is y of 1. And if I actually get rid of that nice triangle, this is x of 2 and y of 2. So that might be helpful, right? So we've got to be super careful how we substitute in. So y2 minus y1. y2, negative 26, subtract y1, 14, divided by x2, 29, subtract x1, 39. Straight to the calculator, right? Straight to calculator. You could type this in without any problem. In fact, let me show you how to do it on the calculator. So if we go to our TI Inspire, you can see that it's a fraction to put in. So we press Control Divide. We have a numerator and denominator. The negative button is here next to the enter. Negative 26. Subtract button is different to the negative button. Subtract 14. Then press the arrow down on your keypad, and you've got 29, subtract 39, enter, there it is 4. Okay, so we've got the gradient is 4. So that's the gradient is 4. Okay, so immediately I'm going to find the gradient of the perpendicular to CD. Now this is 4 over 1 here, so it's 1 over 4 and a negative, right? That's the gradient of this line here. So that's great news, look, because we said it was going to be a negative. Now step 3 is we need to find a point that this line goes through, and this line is a bisector, so it's actually going to go through the midpoint of CD. So if I just go and get the CD is here, and here is the line we want, and you can see that, look, it's the midpoint, right? This is the midpoint of CD. Now let's just see on a formula book, is there a midpoint formula? There is, look, there's a midpoint formula here. Okay, so the only two formulas you really get for this is the distance formula and the midpoint formula. So let's go and use that midpoint formula now. So the midpoint formula, I won't copy paste it across, it's x, I need to put that off. It's x1 plus x2 over 2, comma y1 plus y2 over 2. Let's go sub in x1 plus x2, 39 plus 29 over 2, comma, and then 14 plus negative 26 over 2. Now when you put that in your calculator, you should get a nice clean answer. And the simple answer you should get is 34, negative 6. So there is the midpoint. Alright, so look, we've got the gradient of a line. We've got the gradient of a line. We've got a point that the line goes through, right? There's the point here. and there's the line we need. So now it's a good old y equals mx plus c. Okay, so let's go and put that in. Oh, that's the previous question. Let's go to a new page. So we've got y equals mx plus c. We know the m is negative 1/4. We know it goes through the midpoint, and the midpoint coordinates are 22, negative 3. Let's go and sub all those in. Okay, so the negative 1/4 goes here. The x is 22 goes here. The y is negative 3 goes here. And then we've got the c that we can find. Okay, so let's go and sub all that in. Negative 3 equals negative 1/4 times by 22 plus c. Now you can do a bit of algebra rearranging, but come on, we've got our calculators. Let's go back to our beautiful TI Inspire again. And we're going to go Menu, Algebra, and Solve. So just type in exactly what the equation was. I'll just show you what it was on the screen here. Let's get it side by side. There we go. Negative 3. Oh, let me click on the right one. Negative 3 equals, now control divide gives you that nice fraction button, right? This is negative 1, and then arrow down 4. There's negative 1/4. Arrow to the right, times by 22, and then plus a c. We need to solve that, but if we press enter, it says there's something wrong. So after we have an equation, we have to put a comma and then the variable we're solving for, comma c. Okay, boom. So c is 2.5. Let's go back to our iPad. So c equals 2.5. So now let's write the equation, and that finishes part A. Y equals negative 1/4 x plus 2.5. That's the equation of the perpendicular bisector. Right, let's go back to the question. Oh, my bad, it's all the way back here. Let me just go and get some space on here, and then we can go do part B and part C. I'll just zoom in a little bit here. So part B, it says hence, so we're going to use our answer for part A. So we've got y equals negative 1/4 x plus 2.5, right? Let's go and highlight that in red. That is this line here, that's this edge of the Voronoi diagram, and it's asking us to find the intersection V2. So we need another line to intersect with it. So we could use this line here, the purple line, or we could use the blue line. Now let's see, which equation have we got? We've got this guy, which says it's the perpendicular bisector of AD. Oh look, it's this guy, it's the purple line, look. So we've got the purple line here, which is y equals x minus 25, and I'm going to go over this. We've got the red line, which is y equals negative 1/4 x plus 2.5. So can you see we've got two equations. The simplest way of solving this is the calculator one more time, your best friend. Menu, algebra, solve system of linear equations 2, and we've got x and y, and just go and type in exactly what you see. Y equals, and control divide, negative 1, arrow down 4, arrow to the right, times by, put a times by x, and then plus 2.5, arrow down for the next equation, y, well that's a w, you can go back with a little delete button here, y equals, there we go, sometimes you lose things, right, x subtract 25, off you go, and there you go. You've got the intersection point now is 22, negative 3. So that's this vertex here. Okay, so let me just go and do a little tidy up again. Little tidy up, little tidy up, little tidy up, little tidy up, little tidy up. Okay, there we go. And now finally we've got part C. Determine the optimal position for a toxic waste dump. So a toxic waste dump means that's not great, toxic, that word gives it away. We want this to be as far away from a town as possible. So now we have to test this vertex and we have to test this vertex. Remember, When we're building things, it will always be on a vertex. So let's go and think about this. Can you see that from this vertex, D and C and A are pretty close, and actually if we drew a circle it would go through all of those 3 points. Alright, so vertex V2, we can find any of those distances. For vertex V2 we can find it to A or to C or to D. So that's what we've got to test out. We've got to test out what distance is vertex V2 to one of those letters. So let's do V2 to, what about V2 to A? So we have to do that one. And then can you also see that if I just go ahead and delete that now to make it clearer, we also have to test vertex 1. And you can see that vertex 1 is close to B and C and A. It looks quite close actually, just visually, but we won't trust the picture until we do the calculation. And you can see that that circle here would go through those points. So we have to test V1 with any of those 3 points. And can you see, look, A is to this point and A is also to this point here. So let's go and test V1 with A. So that's how to do this last part. We have to find V2 to A, the distance, using the distance formula, and V1 to A using the distance formula. So let's just go and finish that off. And this time I won't transfer the distance formula because we kind of know what it is, hopefully, but what we will do is down here V2A, we will definitely write down the coordinates that we're working with. V2 was 22, -3. B. And A is listed at -1,4. So the distance equals the square root of x1, x2, subtract x1. That's really important that you put the negative in there. And then y2 minus y1 squared. Okay, so it's important we have all of these in, right? Now when you write that on the calculator, you're going to press Control squared to get the red. Open a bracket, 22, the subtraction button, -1, arrow to the right, hit the squared. So we do it all in one go, we don't do it in pieces. And then plus, open bracket, negative, not the subtract button, the -3, subtract 4, arrow outside the bracket, and we square that and press enter. And then we get 24.04 kilometers. Now we do the same thing with V1 with A. Now V1 is at 22, -3. Oh, sorry, my bad. That was V2, right? V1 is listed here. Okay, there we go. 18, 13, and A is the same as before, -1,4. So D equals, let's do the distance formula again. I'm going to set this up. And it's the x subtract the x, so 18 subtract -1, and then the y subtract the y, 13 subtract 4. Let's go ahead with our calculator, and we're going to do this, and then we're going to type in open bracket here, and we're going to put 18 subtract -1, arrow to the right, and then squared, and then plus open bracket 13 subtract 4, arrow to the right, and then squared. Press enter, and oh, can you see, look, the bracket wasn't here, so there's an error here. So we're going to go back up, press your arrow up, up, press enter, and we can go back with our arrows on the keypad, and we can edit this. So we need a bracket on the left hand side, click, and then we need a bracket after the 4, click, and you'll see there'll be a different answer here, and there it is. So 21.02 kilometers. Now remember, this is a toxic waste dump, so we want it as far away as possible, and so let's just go and have a little think about this. From vertex 2, the distance to each of these sites is 24 kilometers approximately, and from vertex 1, the distances here, they look a lot closer, right, visually, is 21 kilometers. So the vertex 2 wins, and this is where we build our toxic waste dump. We build at vertex 2.